Hey YouTube, I'm Jonas. Welcome back to my channel. Today we're gonna solve the 0, 1 matrix problem. So we're given an n by n binary matrix. We need to return the distance of the nearest to 0 for each cell. So the distance between two cells sharing a common edge is 1. Let's look at an example. So for this example, we consider that every cell with the value 0 has the distance 0 to the nearest to 0. So all of them are 0. And for this one, the nearest distance for this cell is just 1. Because in horizontal and the vertical way, the nearest cell with the value 0 is 1. So in the output, all the values are 0 except the center is 1. So for this example, all these 5 values are 0. So in the output, they're all zeros. And for the center one, the nearest 0 for this one is 1. It's obvious. Same thing for this one and this one. For this bottom one, it's kind of different because for the top, left, and right, all of them are 1s. So we need to move 2 steps in this way or this way to access the nearest 0. So for this one, the distance of the nearest 0 is 2. So how are we going to solve this? Based on our analysis, we may want to start from the 1 and to see the nearest 0 of the given cell. However, when you try to implement this in code, you will find that for every one, you need to search the 4 directions, and it may have some redundant work to do. Because like for this one, you search 4 directions and to see the nearest distance of the 0. And for this, you need to search 4 directions. And for this one, you also need to search 4 directions. So if it's a large grid, you may have some runtime error in your code. So basically, if we start from the single cell to conduct the BFS, breadth first search, it's called the single source BFS. Typically, single source BFS is commonly used in finding the shortest path from one point to another, something like that. Problem, we can change our perspective from the 1 to 0 to see how far is the 1 to the given 0. So like we have 5 zeros initially and process them simultaneously to perform the BFS. All right, so like for this 0, we will search its 4 directions to see if there is any 1 for this 0. So the right direction and the bottom direction is 0, so we will do nothing. And for top and left, it's out of boundary, so we will not consider it. And we take a further step to this element, and same thing, we will search its right, it's 0, and left is 0, top is out of boundary. And for this one, we see this is not the 0, and we should consider it into our calculation. So we see that distance is 1. So we will update this distance to 1. Again, for this 0, all the 4 directions are not valid, so we will do nothing. And for this 0, we will see the bottom is 1. So same idea for this element, we will update it to 1. And because this element has been updated, we will not count it twice for this cell. And then for this 0, same idea as this one, and we'll update this to 1. And then for the initial zeros, we have updated all the distance for its neighbors. So then we will go to the next layer for this one to search its neighbors. So basically, these 3 values are in the next layer, and we are going to perform the BFS for these 3 elements. And for this one, because the left, right, and top have been visited, so we will just search the bottom one. And because distance between these 2 nodes is 1, and the initial value of this is 1, so the entire distance for this one to the nearest 0 should be 1 plus 1. So it will be 2. Okay, so we have searched for directions for this one, and we move to the next value, this one. And for the top, it's visited, and the right is also visited, and left and bottom is out of boundary, so we can skip this. Same idea for this. And then we move to next layer, which is this 2. And regarding this element, 4 directions have been visited, so we end our iteration. All right, so for this solution, we basically form the BFS for multiple nodes at the same time and do this layer by layer. So basically, this is the first layer, and this is the second layer, and this is the last layer. For every layer we perform BFS, it's multiple source, so we call this multiple source BFS. It's commonly used in the problems that need you to like find the nearest neighbors or the nearest value given the specific conditions. So you need to be familiar with both BFS and implement them quickly in your code. So let's see how we're going to do this. All right, so let's implement the multi-source BFS. So basically, single source BFS and multiple source BFS are based on the same idea, but they're kind of different in some implement details. Let's see how we're going to do this. So first, if the mat is empty, we will just return the empty value. Then, same as the single source BFS, we will have some basic variables to support our implement algorithm. We will have the length of the rows and columns, and the directions, the top and bottom, left and right. For this problem, we will have a distance matrix to record the distance of the nearest 0 for each cell. So the dist is going to be, so initially the value should be infinite to indicate the distance is infinitely large, and we'll update it in our BFS. And also we will have a queue to implement the BFS. And in Python, we'll use the collections.stack to implement the queue. So different from the single source BFS, we will append all possible elements into the queue in the initial step. What are we going to do is basically to traverse the whole matrix and to find if the current value of the cell is 0, because we want to start from the 0 cells and to see the values of its 4 directions. So if the value of the mat is 0, we will set the corresponding position for the distance matrix to 0. And then we will append this position into the queue. So we have appended all the potential elements for our breadth first search. So we will then pop out elements of the queue. And the queue is not empty, we will continue our popping. We will have the current position, current I, current j, of the elements that popped out. Then for the popped out element, we will check for directions of it. And we will have the next position based on the current position and the direction. Then same thing like the single source BFS, we need to check if the next position is out of boundary. If all these conditions are satisfied, then we will check the distance value. So initially for this one, the value of this cell is infinite in the distance matrix. So when we currently visiting this 0 and search the bottom value in the grid, we want to see if the current value of the distance plus 1 is smaller than the value of the next position. So basically, we will see if the distant value of the next position is greater than the distant value of the current position plus 1. If so, we will update value of the next position, make it equal to the current value and plus 1. Like the current value is 0 and plus 1 is 1, so this distant value will be 1. And same thing for this position, If we search the bottom element, it's infinite initially, right? So it's larger than the current value plus 1. And then we will update this value of the next position to be the current value, which is 1, to plus 1. So it will be the 2. Then we will append this cell into the queue to make it to be the element of the next layer to be searched. All right, so when the queue is empty, we know that we have visited all the possible elements in the grid. Then we will return the distant matrix. All right, so let's see the result. Oh, there's a typo here. Right bracket should be here, right? So let's submit again. All right, so the algorithm is efficient and we solved this problem. Thank you all and hope to see you in next video.